Okay, hello, and welcome back to this fifth lesson of Introduction to Trigonometry, or an helicopter overview of trigonometry. What I mean, again, by helicopter overview, some of you here in California, you start taking this concept of sine and cosine in grade 7, early grade 8. It's the opposite side divided by the hypotenuse, but then, we explained how did that come from and where did it come from. And then there's a gap. You go taking your algebra 1 and your geometry, and then in grade 11 and 12, you come back to laws of sines and laws of cosines and Herons Formula to find, the area of a rectangle, of a triangle. And that's all good and great, but this is when, this gap, this is what we're working on. We're working on cementing this gap. So for you to understand, that's why I'm giving you what you learned, the formulas in this helicopter overview, the formulas that you learned in grade 8 and 9, and after the gap, the ones that you are learning in grade 11 and grade 12, and some of them are questions on your standardized testings of SAT and ACTs, which many students end up just memorizing them. And that's not what we want to do. We want to understand why we have all these formulas. These formulas, actually, they help you figure out, like, for example, the laws of sines and the laws of cosines. When we get to that, not now, we're going to explain the nitty-gritty of how we came up with this formula of the law of sines or the law of cosines. We're going to use a lot of constructional geometry and Ptolemy laws and Pythagorean and other, known laws of geometry. However, what I want to put in the back of your mind is, I don't know if you know somebody who has a business, a restaurant or a coffee shop, and as a business strategist, you don't go open a restaurant or a business in a dead-end street. You open it on a busy intersection in a touristic area, in a strip mall. And it's always location, location, location. For us in trigonometry, it's location, location, but it's the location of the quadrant. So if we are in quadrant 4, we need to study where do the angles and the tip of the vector that are going to make those vertical and horizontal breakup of that vector fall, on the positive x-axis or on the negative x-axis, on the positive part of the y-axis or on the negative part of the y-axis. So again, everything has to do with location, the location of the quadrant. Okay. Now, the last thing we did was dealing with special triangles, and we dealt with all these special triangles that have complementary angles. And the two best special triangles that we know are, we said, the 1, 1 with the hypotenuse of square root of 2, and the other one is the half of the equilateral triangle adjacent to the 60 degrees, where your equilateral angle is the 1, hypotenuse is 2, and the other leg is the square root of 3, which all of you should know. Square root of 3 is 1.7320. Okay? Now, having said that, there are some angles that are easy, but, and they're complementary. Let's say sine of 15 and 75 are complementary if it falls within a right triangle that's 90, 15, and 75. But it doesn't have any special triangles with known sine and cosine that we use in math. So what do we do in this situation? This is where we're going to start right today, okay? But yesterday, let's go back to some of the stuff that we discussed yesterday. In addition to going back to this magical hexagon that will help you not memorize any of that simple identity and product identity and reciprocal identity and quotient identity, we also, I said, and I told you, if you don't know your 18 chain, that means 18 times 1, 18 times 2, because pi is 180, is 18. You can do this. If you're skipping a quadrant, that means you're going a pi, 180 degrees. So if we are at 135, which is 3 pi divided by 4, you add your pi, which is 4 pi divided by 4. So you end up at 7 pi divided by 4, which is your 315. And we said this is our vector. This is the tip of the vector. We not imagine it, this is where it is actually. It's right here inside of quadrant 4. So this is where the tip of the vector, the projection on the x-axis is your vertical component, which is in the negative. That means sine of what? Sine of the reference angle. Because I got a question yesterday telling me, okay, the angle is 315 and I started here at 0 and I went 315. What's my reference angle? My reference angle, like I said, tip of the vector, perpendicular to the x-axis. And how do I get to it? I get to it from here, from the x-axis to the terminal side. This is my reference angle definition. So it's minus 45 actually. So I'm looking for the sine of minus 45 degrees. What's the sine of minus 45 degrees? The sine of minus 45 degrees is minus sine of 45 degrees. Why? Because the vertical component is parallel to the negative side of the y-axis right here. So the y's, the sine, are negative in quadrant 4. Again, location of the quadrant, location of the quadrant, location of the quadrant. Which quadrant are we dealing with? However, the cosine of minus 45 degrees or cosine of minus theta or alpha in quadrant 3, in quadrant 4 is positive because it relates to the positive x-axis. That's why if we take this special reference angle with this special formed reference triangle, the cosine of minus 45, this is your minus 45, equal the adjacent sine, which is what? 1 plus 1. Look at it. It's plus 1 divided by square root of 2, or plus square root of 2 divided by 2. So in quadrant 3, cosine of minus theta equal cosine theta, or plus cosine theta. However, sine of minus theta equals minus sine of theta because of the location again. Okay, now, and we also, I didn't want to, overwhelm you yesterday. We did this 3 pi 135 plus pi, which is 180. We end up at 315 because we skipped one quadrant. So we're adding a pi, a 180. And that's why most of the time in these situations, the denominator stays the same because you can add your, you multiply by 4 and by 4, you end up here. However, if you're not skipping a quadrant, if you're going, let's say, from quadrant 1 to quadrant 2, and you're going to 5 pi over 6, okay, to your 150. 5 pi over 6, again, is 150. And you don't start with pi over 6. If you start with pi over 6 and you add your 90 degrees, you're not going to make it. This is not your 150 because 30 plus 90 is 120. It's not 150. You start with the complementary of your 90 degrees. And why is that? That's because, if you think about it algebraically, this is your LCM. LCM, lowest common multiple, again, last year of elementary school, grade 5, grade 6, lowest common multiple of 2 and 3 is 6. We want to end up at 6, that's why. Again, integrating everything, LCM, GCF, proportions, ratios, equivalent fractions, simple laws of a triangle that we're going to get to in a second, that you learned again in your first and second year of middle school. So all these things have to be present in the back of your mind in order to dig deeper and connect all these dots and all these formulas of trigonometry together. Okay? Now let's not waste any more time. Let's actually say that we want to find out the sine of what do we have here? 5 pi over 6. Let's stay with the 150. And we forgot that it's what? We forgot that this is 150. Sir, you always say it's 150. I don't memorize that. I don't know that. What do? Again, you don't do anything. You don't memorize. Memorizing these little things is not going to help. You need to convert it to degrees, right? And again, we don't memorize the formula to convert. We use A over B equals C over D, meaning equivalent fraction. You can use, like I said, equivalent fractions for many things. You can use equivalent fractions for a small volume on top and the large volume, small cylinder inside a larger cylinder. this equals, and or is equivalent to the height, for example, of the small cylinder and the height of the larger cylinder. You can use small area and the larger area, and that's going to be equivalent to whatever you're studying. You can use, like we said, we used that in the past, in the previous lesson, with the S, the length of the arc, which is part of what? Of the whole circumference, C. You can use that with, elements of one entity. When you use 20 miles per hour, yes, they're different units of measurements, but they belong to, one entity. One car is going at 20 miles per hour, okay? So same here, what is, with the units of measurement, same, that when you say, like, let's say 1 foot is 12 inches. For one entity, for any entity, 1 foot is 12 inches. And then if they give you that, you have another entity that has 18 inches, you do your cross multiplication and you find the fourth element. So you can use this with any common sense, that you can put part divided by whole, or smaller volume, smaller area, smaller sector divided by the larger one, or elements belonging to one entity, and then we are comparing that equal the second entity. So here, what do we have? You always have pi or 180. And what's 180 for any circle? Is pi. So I stack them up like this. And then I stack up my 5 pi over 6. And look at that. I can get rid of my pi's. And all I'm doing here, I'll go back to the 18 that I told you about. To find out this one, you have to do 18 or 180 times 5 divided by 6. And you end up with 150. Okay? That's it, 150 degrees. So, and once you have your 150 degrees, what do? Well, once you have your 150 degrees, again, 150 degrees, you need to first location of the quadrant. So where is that 150 degrees? That 150 degrees is right here in quadrant, and I got to it this way. Okay? It's in quadrant 2. So what's the reference angle of this 150 degrees? The reference angle is 30 degrees. So 30 degrees is right here. This is my 30 degrees. This is the special triangle. I can sketch that special triangle on the side. So this is the 30 degrees, right? And this is, of course, the 90. And this becomes the 60. And we said the 60 is part of the equilateral triangle. So adjacent to the 60 is your 1, hypotenuse is 2, and the square root of 3 is here. So if I'm looking for, let's say, cosine of, we started with 5 pi over 6. So I'm looking for the cosine of this. What do? It's adjacent divided by the hypotenuse. But the adjacent side is where? Is in the negative, because it's relating to the negative side of the x-axis, to the minus axis. So it's minus square root of 3 divided by 2. And that's it. You're done. And we didn't memorize anything. All we did was conceptualizing this special triangle. Okay? That's all we did. Now, if you have something in, let's say, in quadrant, make it a little bit more difficult, in quadrant 4, and they tell you what is the tangent of minus 45 degrees. Once you see a minus, this tells you that you started, clockwise. That's the first thing you need to know. So you started clockwise and you went minus 45 into the dark, or you're right here. The tip of the vector goes like this. This is your reference. This is the triangle that you built. You started with minus 45. Okay, so this is 1, and this is square root of 2 because you have a 45. This is the other special triangle. We have two special triangles. The 45, and it's isosceles with hypotenuse of square root of 2, and the 30, 60, and 90 degrees. Okay, so here, tangent is usually opposite divided by what? It's opposite divided by adjacent. Okay, you can skip the hypotenuse. So or it's sine divided by cosine. And the sine is negative here, okay? It's minus square root of 2 divided by 2. And the cosine is positive. We just did it. So the answer is minus divided by plus is minus 1. Okay, let's go deeper into something that is not even. Okay, let's say they ask you, what is the sine of 10 pi divided by 3? And you'll be like, what do I do? You know, you told me not to memorize anything. Okay, I told you not to memorize anything. First, let's look at this pi. This is a very large fraction. That's just 3 pi. 10 divided by 3 is more than 3. 9 divided by 3 is 3. So this is more than 3 multiplying more than half the circle. So basically, you passed the first rotation. This is how I approach it. You passed the first 360 degrees. You're beyond that. Oh, okay. So I need to minus. The goal is to start with an angle between 0 and 360. You passed that. So all we need to do is just minus 360. But first, how do I get to the degrees? We just did it. We don't memorize it. We stack them up. 180 degrees divided by pi of any half circle, right, is equivalent to 10 pi divided by 3. Pi and pi go away. And then you do 180 times 10 divided by 3. So that's 1,800 divided by 3. So that's 600. It's 600 degrees. So now I know it in degrees. So once I know it in degrees, I can go ahead and do 600 minus 360 degrees. What do I end up with? 240 degrees. And it'd be like, oh, okay. Now you told me location, location. Again, exactly, location, location, location. Where is the location of the 240 degrees? Again, we call that coterminal angle. That means this 600 is the same as your 240 degrees because you added another 360 to it. Okay, so it's right here. It's in quadrant 3. So this is the tip of the vector. This is my 240. So I can draw it like this. Okay, and I can say, okay, what's the reference angle now? The reference angle is, anyone? Okay, you can text me that. Yeah, the reference angle is the angle between the terminal side, which is the vector itself, and the x-axis. So 60. 240 minus 180 is 60. It's right here. So if 60 is right here, remember, that's the special triangle with the 60, 90, and the other one will be 30. So adjacent to 60 will be what? 1. Hypotenuse is always 2. And on this side, I have square root of 3. So the sine is what? Sine of 60 in quadrant 3. Okay, sine of 60 equals what? Equals opposite, which is square root of 2. I'm sorry, square root of 3 divided by 2. Okay? Square root of 3 divided by 2. And that's your sine in, I'm sorry, it's minus. Yeah, it's not quadrant 2, it's quadrant 3. They're both negative. The sine and the cosine, look at it. Even the square root of 3, it's in the negative, okay? I am overwhelmed again. All these formulas, you know, and the trig and the trigonometry, if you memorize them, you're not going to do very well, I'm sorry, unless you're lucky on a test or something, okay? So yes, the vertical component, it's in the minus. So sine of 60, which is the reference angle to 240 in the quadrant 3, in the third quadrant, is your minus square root of 3 divided by 2, okay? Now let's do something a little bit, not difficult. Again, let's do this. Let's say we're in the negative. What can we do? We can do sine of minus 800 degrees. You don't have to convert to radian here. I gave it to you in degrees right away. So what do? You're in the darkness. You don't minus 360, you add the 360 until the goal is to get to that angle between 0 and 360 degrees, okay? So you add 360, minus 800 plus 360, that I believe is minus 440 degrees. You're still in the dark. You can add another one. So minus 440 plus 360, that will give you minus 80 degrees. Okay, so minus 80 degrees, you can still do another what? You can still do another 360. So minus 80 degrees plus 360 equal 280 degrees. Now you're in the light and you are within that first rotation between 0 and 360. Now your angle, right, is what? 280 degrees. So you're looking for the sine of 280 degrees. Now let's locate the quadrant. Okay, where is the quadrant of 280 degrees? It's in quadrant 4, exactly. So we're not, inventing anything. This is not magic. So this is right here. Okay, this is your 270 right here. And 280 comes right next to it, right here. So basically, this is your angle. So what's your reference angle? Your reference angle is this minus 80 that you just did. You came up with, right? Because the reference angle is between the terminal side and the x-axis. So your reference angle is minus 80. So what's sine of minus 80 degrees? It's minus sine of 80 degrees. We just did it. And we said, because it's in quadrant 4, if you draw the tip of the vector, the vertical component is in the negative and related to the negative side of the y-axis. Does anyone know what sine of 80 degrees? I've been doing it for a while. I know it. 90 degrees is 1, sine of 90 degrees is 1, the sine of 80 degrees is very close to it. It's gonna equal minus 0.984. Now, if you don't know that, what do? What can you do actually in a situation like that? This is, can you, for instance, do like this? Can you go, and this is very important, please pay attention here. So, you don't know, can you break that 80 degrees into angles that you know? For instance, I also know 35 because I've been doing, this for a while, almost all my life. The sine of 30 is, a half, which is 0.5. The sine of 35 degrees is around 0.57, a little bit over 0.5. But let's say I want to come here, I want to do, what do? Can I do that? Can I do, let's say 80 degrees is 45. I know the 45, they're part of the special triangles, plus 35. Yeah, you can do that, but how do you get them out of here? And please pay attention here. Can you go and say sine of 45 degrees plus sine of 35 degrees? Absolutely no. No, no, no. And this is a big no. Okay? The sine and the cosine, because they are representing an angle that is related to time, that is moving, and that you can break up. You cannot do a distributive property with it. You can't do that. You can never do that. Look at it. If you do it like this, what's sine of 45? Sine of 45 is square root of 2 divided by 2, which is around 0.7, I believe. And sine of 35, I told you, it's 0.57. So the answer will be 1.27. But we just said the answer. And this is more than what? 1. So it's wrong. There is no sign that is more than 1. All the signs are between minus 1 and plus 1. Remember that? It's a proper fraction. So, rule. This is like, there is no distribution. We don't distribute. This is not multiplication. We don't do that. We never do that with sine and cosine. Okay? So what do we do in a situation like that? In a situation like that, this is, again, the gap. You learn that in grade, unfortunately, 8, and then there is a gap, and then in grade 11 and 12, you learn the laws of the identities of the angles, the sum of the angles, the product of the angles, the difference of the angles. So when you have sine of let's say here you have an angle U plus an angle V. You get them out as sine of U cosine of V plus sine of V cosine of U. Now, when we get to that, we're going to explain how we got it, and we're going to derive it, and I'm going to explain to you how, that's how I help the students not memorize it, how the sine and cosine are like partner, like lobsters, like lovers. They stick together. One of them is greedier. The sine is not greedy. He always goes to the cosine. The cosine always stick with the cosines first. But the only thing you need to know now in this definition, helicopter overview, is that you don't distribute the angles. You don't distribute the sine. This is not a distributive property here. There's never a distributive property with sine and cosine. You get them out by following the sum identity or the difference identity, which, let's try a difference identity here. Let's try a simple angle of, I just mentioned it, 15. If you say sine of 15 degrees, not part, it's in quadrant 1, you locate it, but it's not part of any, it's complementary with 75, but it's not part, it complements 75 complementary angles, but, it's not part of any special triangle. So what do? You can write it like this. Sine of 45, you're 45, and you're 30 degrees. But you have to wait until you go to grade 11 and learn how to get those out. And that's the problem here. Now, that's why we try to link everything together. So this is sine of U minus V. You get them out. The sine is not greedy, and he goes right away with the cosine. Sine of cosine of U times cosine of V, and the minus stays minus cosine of U sine of V. So if we need to follow this, what's the sine of U, which is 45 degrees? It's square root of 2 divided by 2 times cosine of V, which is 30. It's square root of 3 divided by 2. Where did I get these from? From the special triangles. Minus, what's cosine of U, which is 45 degrees? Again, it's square root of 2 divided by 2. And what's the sine of V, which is 30 degrees? It's a half, okay? So if I put them together now, what do I get? I get square root of, let's see here, 6 divided by 2 minus square root of 6 divided by 4, square root of 6 divided by 4, minus square root of 2 divided by 4. Okay, and in one of your ABC answers, you should see something like that. You should see square root of 6 minus square root of 2 divided by 4 if you're not using a calculator. Okay, so that's how you approach something like that. Again, only thing that I had to conceptualize are my special triangles, my two special triangles. Now let's go to cosine complementary angle, cosine of 75 degrees. If the sine of 15 degrees equals square root of 6 minus square root of 2 divided by 4, what's going to be the cosine of the complementary angle? If the sine of 30 degrees is 0.5, is a half, what's the cosine of the complementary of the 60 degrees? It's the same. It's the half. So we're going to end up, with the same answer. We're going to end up with square root of 6 minus square root of 2 divided by 4. If you get a different answer, you did something wrong. And then if we want to split it and break it up, again, there is no distributive property. Equals cosine of 45 here plus 30. Okay? And with the cosine is very greedy, so he sticks with the cosine. So you get cosine of U times cosine of V, so cosine of 45 times cosine of 30. And he changes and we're going to derive it and tell you why when we get to that, the sine. So this is minus sine of 45 times sine of 30 degrees. Okay, now cosine of 45, square root of 2 divided by 2 times square root of 3 divided by 2 minus square root of 2 divided by 2 times, what's the sine of 30? A half. You're going to end up with the same answer. okay? Because they are complementary angle. And again, we studied complementary angle also. They're related to your special hexagon. And your special hexagon, the complementary angle are right here, remember? They go across from each other. Sine, cosine. So if the sine of 30 degrees and the cosine of 60 degrees, they're going to be the same, because sine of 30 equal cosine of 90 minus 30. And same here, sine of 15 equals the cofunction, the complementary angle of cosine of 90 minus 15, which is the cosine of 75 degrees. So everything now should be linked in the back of your mind on how to approach these. Now, let's go into something a little bit more difficult. Let's say you have now an obtuse angle, okay? So let's say 100, no, not 120 is easy because it's part of our special 125 degrees. Let's say sine of 125 degrees. And you want to approach this and you say, what do I do? You taught me to break it up. There is a formula that I'm going to learn later on how to not distribute but break up the sum identity. So I can go sine of 90 degrees plus 35 degrees. No calculator allowed. But do you know what's the sine of 35 degrees? I know because, I've been teaching and tutoring this for years and years and generations. You don't know. And this is not part of the special triangles. So, nah, that's not the way to do it. If you think about it as, okay, so if I think about it as, reference angle, what's the reference angle of this? Okay, so you draw it and you go like this. 125, reference angle is here. 180 minus 125 is 55 degrees. Again, 55 degrees is not part of any special triangles. It's not something that you should know. They don't expect you to know that. They expect you to know the sine of the cosine related to the special triangles only. Okay? So, what do you do in a situation like that? Here comes again the big gap. We have to go to grade 11, grade 12, study advanced geometry, study the law of sines and the law of cosines. And the law of sines and the law of cosines, they're not difficult, but they're pretty much related to the basic idea of what a triangle is, and the laws of equality and inequality, and how to build and construct a triangle. Very simple math or geometry in this situation. So, when you know two sides, okay, let's say you have an oblique. Oblique, that means there is no 90 degrees, okay? Oblique triangle. The oblique triangle could have acute angles or could have one obtuse angle, okay? So let's say you have an angle A and an angle B, vertex and angle B, or let's make it C here and B here. So always in most books, in most textbooks, in front of angle A is side A, in front of angle C or vertex C is side C, in front of angle B is going to be your small side B. Now, again, when we get to that, we're going to explain this equivalent fraction of the same element, which is the representation of that corresponding angle with relation to the corresponding side. And we're going to explain how we got to it. The law of sines tells you sine of A divided by side A equals sine of B. That's what we're going to get to. We're not going to explain it now. We will explain it after the definition, after the helicopter overview, when we really get to it. Equals sine of angle C divided by side C. So basically, if you know two sides, and here we want to, what's the main question was sine of 125 degrees, right? So if you know two sides, and you know one angle to be an angle within one of the special triangles, meaning 30, 60, 45 degrees, then you're good. You can figure it out, okay? So let's say they make it easy for you and they tell you, the corresponding side to this 125 degrees is 10 centimeter. And then you have another 30 degrees. Oh, there you go. 30 degrees is part of the special triangles angle with a corresponding side of, I believe in order to make it, a 6.1 centimeter. So you know two sides, and you know a special angle. The sine of 30 is a half, is 0.5. So all you need to do here, you come here, you do sine of 125 degrees divided by the corresponding side, which is tan, equal sine of 30 degrees, which is what? 0.5 or a half divided by 6.1. And you do your calculation. Let me do it here. 6.1, 0.819. So my answer is 0.819. Again, for those of you who are just starting grade 8, it has to be less than 1 because the sine is a function of frequency that is between -1 and +1. And when we animate it, when we're going to draw it and graph it, it's going to be between -1 and +1. So all the answers have to be between -1 and +1. Okay? And if you are to draw this triangle now, let's say you have another question and you need to sketch it. So that's what you do. You come here, you have your obtuse 125. So this is my 125. And I go like this. And I say this is the 125. So this is my A. Across from the A is the 10. Across from the 30 degrees is the 6.1. And if you need to find, you know, the other ones, the sine of C. So if this is 125 and this is 30, what's this one? It's 25 degrees because the total has to be 180 degrees, okay? So now you have all the pieces of the puzzle. You have the third angle, which is 25 degrees. So you can find the sine of 25 degrees, or you could be given this, or you can calculate it if you have a scientific calculator and if it's allowed, and then you can find the last side, C. Okay, that's one way to approach this. Now, but this law has a lot of ambiguity, and we're gonna get to that in a second. Now, but before we get to that, let's say they gave you the three sides. You know the three sides, and we have, you need to get, this sine of 125. Sine of 125 degrees. So, but three sides. The first side is A, or they don't tell you 125 degrees. Until you find the sine of this angle A. We put it as A here. Sine of angle A. And you have A side equal 10 centimeter, B side, same thing, let's make it 6.1 centimeter, and C side, what is it going to be, I believe, 5.12 centimeter. So 6.10, 5.12, and 10 centimeter. And they tell you they have the three sides. You need to start by finding the angle that corresponds to A, okay, which is sine A. You need that sine, the sine of the angle that corresponds to the largest, keep that in mind because we're going to talk about that in a second, to the largest side and the largest angle. The largest side here is 10, so the largest angle must be A, okay, 125. Okay, but let's figure that out. When you know the three sides, you use the other law, the law of cosine, which we are going to define and derive and tell you how you get to it and how you use it without memorizing. It basically goes, if you know three sides, one of them squared equal the other one squared plus the third one squared minus those two and the cosine of the angle between them. Because look carefully. If this is C, this is C. If this is B angle, this is B. So the angle between B and C is A, and the angle between B and A is C. It's always like that. This is not something that you need to memorize. So if I go back to my law of cosine, and I'm squaring the sides because I know all of them. I know this and this and this. I only need to find the angle, okay, sine of that A, which is 125. We'll get to that in a second. So A squared is 100, 10 squared is 100, equal B squared 6.1 is 37.21 plus c squared is 26.21 minus BC, those two angles, 62.46 cosine of that angle that I'm interested in, A. If I flip and I move the A to the other side and I move everything to the other side, I get cosine of A equal, divided by that number multiplying the cosine of A, 62.46. And on top, I go 37.21 plus 26.21 minus the 100. Very simple. I didn't, this is very simple and easy math. 141, okay. So I get equal minus 36.58 divided by 62.46. And if I calculate that, I get minus 0.5, I'm sorry, minus 0.585. It's approximately minus 0.59. Okay, again, makes total sense. Why? Because we already solved that, and we know 125, we don't know it now, but we solved it with, the previous one, and we know it's in quadrant 2. And in quadrant 2, the cosine is negative. It's related to the negative side of the x-axis. But you tell me, but we're looking for the sine of that angle. Yes, you're looking for the sine of that angle. And then we go again, what is cosine square alpha or theta or amount of rotation plus sine square of amount of rotation is 1. Okay, so sine square of any angle equals 1 minus cosine square theta of that angle equals 1 minus 0.59 squared. What's minus 0.59 squared? So that's equals 1 minus what was that? 0.35, approximately 0.35, which is approximately 0.65. But that's the sine squared. Now the sine A should be what? The square root of 0.65. Let's do square root of 0.65. And we get approximately 0.81. And what did we get in when we used the law of sines? Let's go back up there. We got 0.819. That's it. So you can approach it depending on what you have. When you're in grade 11 and 12 and you're studying for your SAT and ACTs, you have two laws. You have the law of sines, which we will derive and explaining how we got to it, and the law of cosines. The law of cosines, we use it when we know the three sides. But we have to start with the largest angle. And I'll explain that in details very soon in the next example, because there is a big ambiguity that comes with the law of sines, whether we really have a triangle in existence or we don't when we're constructing this triangle. And the law of sines, if you know two sides and the third angle is an angle that is known to you, like a 30, 60, or one of those, complementary to 45, the other 45, or one of the special angles in quadrant 2, like the 150, the 135, the 120, then you're good. You can use sine of angle A, and an oblique triangle divided by side A equals sine of B, divided by the corresponding side, which is B, equals sine of angle C divided by C, the side C. But this law comes with a lot of constructional geometry ambiguity that starts with, do we really first of all have a triangle? And what are the laws that govern having a triangle? And what do I mean by this? Well, if you have a triangle, you need 180 degrees, right? So if two of the angle, let's say angle A plus angle B, are more than or equal to 180 degrees, do you have a triangle? Of course not. You don't have a triangle. So basically, if A is here, and B is here, A plus B must be less than 180 degrees. Okay? They must be less than 180 degrees. They should both form, 178 degrees at least, meaning 39 plus 39 and 50 plus 50, so 89 plus 89. So if this is 89 here degrees and this is 89 degrees, so that makes it 178, and this leaves what, 2 degrees here. I'm sorry, 2 degrees here if you're going like this. I apologize. So the 2 degrees will be here in this, and you'll have 89 and 89. The total will be 180 in this situation. If it's more than 180 degrees, first of all, you don't even have a triangle. Now, when we think about a triangle, we have to think about the angles. So let's say you have one side here and one side here, and you're constructing, remember constructional geometry, you're constructing that third one. Now, if this is B and I'm constructing A, and if I know that A is smaller than B, I stop here. I don't have a triangle. So I need to fulfill some restrictions and some conditions before. So in this situation, A must be larger than B in order for me to construct and draw this triangle. A here and B here. So A must be larger and, longer than side B. Okay, very, very simple common sense math. Now, if you followed me with the previous introduction when we talked about ellipses and conic sections, we set a very important condition for any line to be tangent to an ellipse. And we said it's very easy, and we explained it over 2 lessons actually. The line is y equal mx plus c. This constant has to be equal to c squared is going to be equal to the breakfast, we call it, the egg, the breakfast, the ellipse. AM is your morning time breakfast plus b squared. And, we try to not memorize it by thinking about it this way. And that's a condition. You cannot have a tangent to an ellipse unless you fulfill this condition. Same with a triangle. If you're constructing a simple triangle, you need to follow certain laws. I'm going to leave that for the next lesson, but before, I'm just going to remind you of what the new laws that you don't have to memorize now, because we're going to dig into each law separately and how we got to it. The first one is the law of cosine, which when you know the 3 sides, you start with the largest angle, and I'll explain that in the next video why we're going to start with the largest angle. And if you know, let's say b squared equal a squared plus c squared minus ac, and the cosine of the angle between them, which is b. Okay? So this way I can move b to one side and find out this cosine b. And once I know cosine b, what do? It's the inverse function, which is the arc cosine. This is something that you also learn in grade 11 and 12. Every function has an inverse function. The inverse of the sine and cosine is called arc sine, arc cosine. And this is how you spit out the angle. You know the sine, you know the cosine, you find the angle. We will get to that soon. But this is the law of cosines. All you need to know for now requires you to know or be given the 3 sides. The law of sine, okay, is an equivalent fraction. You stack them up, angle over side, angle over side. And you can find an angle if you know 2 sides. And one of the third element is an angle that is one of your special triangles. 30, 60, 45, 120, 150, 135. Then you can find the 4th element. Okay. Now another law that is also left all the way till grade 11 and grade 12 is the area formula. What do I mean by area formula? Area formulas are actually very easy, but they unfortunately leave them for you to deal with them in grade 11 and 12 and relate them to everything that you learned earlier. Now, what's the area of a triangle? Area of a triangle is very simple. Area of any triangle is 1/2 of the height divided by the base. So h times b, height divided by base. So if you have an oblique triangle, not a triangle with a right angle, oblique triangle. Let's call it A, like we did. And I always like to put my B here, I don't know why, and the C, okay? So this is side A corresponding to A, and this is side B, and this is side C. So if I am to find, with what I know, since middle school, the area of a triangle, even grade 5, 1/2 of the height times the base. If I consider the base to be this A, because I'm always interested in this angle A. So this is my base. I know this is equal small a. How do I find the height? I draw a perpendicular from this vertex onto the base, right? So let's say I call it h, height, okay? Now what's the sine of C? Sine of C equal opposite, which is in this situation what? Your h, divided by, what's the hypotenuse of this triangle here? B, small b. So h equal what? H equal b times sine C, I'm sorry. So in this situation, what becomes the area of that triangle? Area becomes half of base, which is A, times h, which is b sine C. And this, they leave that, unfortunately, all the way to, in many curriculums, till grade 11 and grade 12. So one of the things that you're going to learn, so if you know, if you know the area, you can find an angle. If you know the angle between two, between A and B, there is angle C. Or this one could be written this way. BC times sine what? A, because A is between B and C. Or it could be written what? This way. Half of AC and sine B, because B as an angle is between the two sides A and C. So again, all of these, once we link them together, you don't need to memorize any of them. The only one that you're going to memorize when you get ready for your SAT and standardized or ACTs, any standardized testing, is called the Herons Formula. They do ask that in some standardized testing, and in many, I've seen it in many versions. They ask you what's the area of the triangle, and you can do it as with the Herons Formula using the semi-perimeter. And they denote it in many books by S as half or semi-perimeter, being A plus B plus C divided by 2. That's your half or semi-perimeter. And in this situation, the area would be the square root of this S, and S minus A, S minus B, and S minus C. We need to do that once we start getting ready for a test. This is one of the, I will explain how we derived this and how did we get to it. But many students end up memorizing only that one. The other ones that I just talked about, this is common sense. This is your height times your base, half of height times base, the area of any triangle, oblique triangle. And you need to know that if you're talking ABC, if you're calling the angles, the sides ABC, angle C is between AB, angle A is between BC, and angle B will be between AC. And then you just draw your height and use your sine, and you're all set and ready to go. Now, in any right triangle, one thing that I need to mention before we wrap up this lesson, let's say you have an easy right triangle, no oblique. And let's say again that we call this A, I always call this A, call this B, call this C. This is your right angle. And this is side C, small b, small a and small b. Now, if you know an acute angle, let's say you're A, and it's acute here, right? And you know the opposite, let's say the opposite side, you can figure out B. B as a what? As a side. B equal what? Remember, we've been using sine and cosine, but we also need to start using the tangent. The tangent helps a lot. The tangent is always the opposite side in a triangle is this A divided by B. So the tangent of A, we don't use the hypotenuse. The tangent is A divided by B. So if I am to find B, B is A divided by what? By tangent of A. So if I know A, if I know my angle A, I know the tangent. If A is 45, the tangent of 45 is 1. So I can figure out B. Okay? Now, and B is an angle is pretty easy to, decipher. It's 90 degrees minus your A, right? 90 degrees minus your A. Because you know your A, and one of the angle is 90 degrees. You're not an oblique triangle. Again, you're in a very easy right triangle. Okay? And then now here C, what is C? C as a side. C equal A divided by sine A. So if I know A, sine A equal opposite, which is A divided by the hypotenuse, I can also figure out the C, the hypotenuse. Now, I got a question one time, and another smart question right where it was supposed to be asked. What if you're talking about this very simple, right triangle and the acute angle, I got all that, and the 90 degrees, I got all that. What if you have your acute angle and not the opposite, but the adjacent? You use the cosine. That's very simple, okay? So if this is, again, B, and this is your B, and this is small a for the side, small c, and your C. Here, A equals what? B times tangent of A, because tangent of A equal A divided by B. And C as a side equals what? B divided by cosine of A. We use the cosine because the cosine, we know the adjacent side, the cosine of A equals what? Equal B divided by C. Okay? So depending on what you are given, adjacent side you use the cosine, it's very simple, and opposite side you use the sine. And it's super easy inside a right triangle. Should be super easy for you by now after all these fifth, actually, I'm sorry, this is the fifth lesson. In the sixth lesson, we're going to dig deeper into that ambiguity. Why do we have an ambiguity when we use the law of sine and cosines? And which restriction should we put before we start using the law of sine and cosine? I'm going to give you an example, and I'm going to make the mistake. I'm going to show you how, if you don't follow the restrictions, the conditions, then you will end up with a wrong angle measurement. Okay? And on that note, I'm going to wrap up with this fifth lesson, and I will see you in the next lesson with the ambiguity of the law of sine and the law of cosine. Okay? Thank you, guys.